Welcome to our deep dive into algae treatment and wastewater management.
Yes, always a fascinating topic.
We're focusing on a problem that I think a lot of our listeners are familiar with.
Okay.
Those pesky algae overgrowths in wastewater treatment lagoons, especially during those warm months.
Oh, yeah. Big problem.
So imagine you're facing this right now. You're struggling with effluent quality, exceeding permitted limits. Ugh, a real headache.
Right.
Well, we've got you covered today.
Absolutely.
We've got 2 documents from FRC Systems about their DAF technology.
Okay.
And we also have a research paper comparing municipal and industrial wastewater treatment processes.
That sounds good.
And we're going to use all this to help you, dear listener, tackle that algae problem head on.
It's a common issue. I think you're right that a lot of people struggle with this.
Absolutely.
Especially, as you said, during warm weather. You get that excess nutrients, plenty of sunlight, and those conditions. Bam, algae just loves it.
It flourishes. So let's
Yeah.
break it down. Why is this such a headache for wastewater treatment facilities? What exactly happens when those algae levels go through the roof?
Well, a lot of times people are struggling to meet their permitted limits.
Right.
And we're mainly talking about total suspended solids, or TSS.
TSS.
Yeah, all those tiny particles floating in the water.
Okay.
If there's too much TSS, your effluent isn't clean enough for discharge.
Right. That's a problem.
And those excessive algae, well, they're a major contributor to high TSS levels.
Gotcha. And the FRC case study, they talk about this facility. They're struggling with exactly this. A 2 million gallon per day operation just battling high TSS in their lagoons.
2 million gallons a day. Wow.
Yeah. Sounds like a nightmare.
It can be. And it's not just the high TSS levels, it's the domino effect it causes. All
Yeah.
those algae, they die off eventually, right? And when they decompose, they consume so much oxygen.
Yeah.
That leads to what we call anoxic conditions.
Anoxic conditions.
Yeah, basically think of it like this. It suffocates the beneficial bacteria that are supposed to be breaking down the organic pollutants.
So it's not just about the green water.
Yeah.
It's really disrupting the entire ecosystem of the lagoon.
Absolutely. And the worst part, it becomes a vicious cycle. Those decaying algae, they release even more nutrients. And what does that do?
Fuels more algae growth.
Exactly, more algae growth.
It's a never-ending battle.
It can feel that way sometimes.
So how do we break this cycle? Enter DAF technology, right?
DAF can be a real game changer.
Now, I'll be honest. When I hear DAF, I'm imagining big, bulky machinery, lots of complicated stuff.
I can see that.
But the FRC materials emphasize a compact footprint and, get this, minimal operator attention.
That's good. You don't want to be spending all your time babysitting it.
Exactly. So can you walk us through how DAF actually works its magic?
Sure. Imagine tiny bubbles, right? They're latching onto the algae and carrying them up to the surface.
Oh, like little hot air balloons?
Yeah, exactly. Tiny little hot air balloons. It starts with pre-treatment to remove the large debris. Then you dissolve air into the water under high pressure.
Okay.
And when this pressurized water is released into the DAF tank, the pressure drops. And bam! Countless microbubbles are formed.
Wow.
These bubbles, they're like little magnets. They attach to the algae, making them super buoyant and floating them right up to the surface. Then we can skim them off. Easy peasy.
So you're not filtering the water. You're just making the algae themselves easier to remove. That's fascinating. What happens to the treated water then?
Well, once it's free from most of those contaminants, it gets collected at the bottom of the DAF tank, ready for discharge or further treatment if needed.
This all sounds incredibly efficient, but what makes DAF stand out from other treatment options?
Well, for one, it has a high flow rate, so it can handle huge amounts of water really quickly. And it produces a dry sludge output, so disposal is much easier. Maybe most importantly, it uses very few chemicals.
Oh, that's good.
Yeah, much more environmentally friendly.
Those are some pretty compelling advantages, especially for a facility like the one in the case study.
Right.
They're struggling with those high TSS levels.
Absolutely.
So can we dive into that case study? See how DAF performed at a real-world setting?
Let's do it. This pilot study was at a 2 million gallon per day facility, like you mentioned.
Right.
And they wanted to prove that DAF could really remove algae effectively. And they wanted to see how it impacted various water quality parameters.
So what were they measuring? What were the key things they were looking at?
3 main things. TSS, of course, total phosphorus, or TP,
TP.
and carbonaceous biochemical oxygen demand, or CBOD.
CBOD, okay. And remind us, why are TP and CBOD important?
Right, so high TP, that contributes to algae overgrowth.
Makes sense.
And high CBOD, well, that tells us there's a lot of organic pollutants. Both of those lead to those oxygen-depleted conditions we talked about.
Gotcha. So it was like a multi-pronged approach.
Yeah, they wanted to get to the root of the algae problem.
Address the root causes.
Ex
So what did the DAF system actually look like in this case study?
Well, they had a DAF system with a maximum feed flow of 20 gallons per minute, and they used a flocculator, too.
What's a flocculator?
It's a device that helps clump those algae particles together so they're easier to remove.
Ah, clever.
Yeah, it's like making bigger targets for those microbubbles.
I like it.
They positioned the DAF system right next to the lagoon. They pumped the wastewater through the flocculator and into the DAF tank. The treated water flowed back into the lagoon. And the separated sludge, they collected that separately.
Sounds pretty straightforward.
Yeah.
So the million-dollar question, did DAF deliver? What were the results?
The data from their 6-week pilot study is pretty amazing. The DAF system significantly reduced all 3 parameters. TSS reduction was between 66.93% based on the owner's analysis and a whopping 87.08% based on independent lab results.
Wow, that's a huge difference.
It is. And that independent verification is important. Shows that DAF wasn't just a fluke.
Absolutely. Did they see similar reductions in TP and CBOD?
Absolutely. TP reductions were between 53.74% and 95.57%.
Wow.
And CBOD reductions ranged from 73.40% to 86.07%. So, yeah, DAF really knocked it out of the park.
Those are some pretty impressive numbers.
Yeah.
It sounds like DAF lived up to the hype. It provided a real tangible solution for this facility that was struggling with algae overgrowth. But I imagine every wastewater treatment setup is different, right?
You're right. Every situation is unique.
This case study focused on a municipal wastewater treatment facility. But to understand if DAF could be a solution for our listeners, we need to look at the bigger picture of wastewater treatment, right?
Absolutely.
For example, industrial wastewater, that often requires different treatment methods.
It does. It's a whole different ballgame.
So let's shift gears a little bit and explore those different types of wastewater treatments, see where DAF might fit into the bigger picture.
Sounds good to me.
So we've been talking a lot about algae and DAF, but you mentioned industrial wastewater treatment. What makes it so different from the municipal treatment we've been discussing?
Well, the main difference is where the wastewater comes from. Municipal wastewater, that's from our homes and businesses, right? Sinks, toilets, showers, that kind of thing.
Makes sense.
But industrial wastewater, that comes from all sorts of industries, like manufacturing, energy production, food processing.
So it's not just about the volume of the wastewater, but also what's actually in it.
Exactly. Municipal wastewater is pretty predictable, but industrial wastewater, that can contain a whole bunch of different contaminants. It all depends on the industry.
Gotcha.
You might be dealing with heavy metals, oils, chemicals, even radioactive materials in some cases.
Okay, yeah, that does sound a lot more complex than dealing with what goes down the drain in a typical household.
It definitely can be. Industrial wastewater often needs very specialized treatment processes, tailored to those specific contaminants.
Makes sense.
For instance, let's say you've got heavy metals. Well, one technique is chemical precipitation. You add certain chemicals to the wastewater, and they react with the heavy metals, causing them to form solid particles that can be separated out.
Like a targeted attack on those heavy metal villains?
Exactly.
What other specialized techniques are used?
Well, another important one is adsorption. You use materials with a high surface area, like activated carbon, to trap and remove those contaminants. It's kind of like a molecular sponge.
So it's like filtering coffee, but on a much, much smaller scale.
Yeah.
What kind of contaminants would you use adsorption for?
It's really good at removing things like toxic organic compounds and color. Imagine a textile dyeing factory. If they don't properly treat their wastewater, all those dyes can end up in the water. Adsorption helps keep our rivers from turning into tie-dye masterpieces.
Okay, yeah, that's a pretty vivid image. Any other advanced techniques you'd like to highlight?
Yeah, advanced oxidation processes, or AOPs, are becoming really popular these days.
AOPs.
AOPs. They use powerful oxidizing agents like ozone or hydrogen peroxide to break down stubborn organic pollutants that don't respond well to conventional methods.
It's like sending in a molecular SWAT team to neutralize those pollutants.
That's a good way to put it.
What are the advantages of using AOPs over those other methods?
Well, they can be really effective in treating a wide range of contaminants. And they don't produce a ton of sludge, which is good for the environment and simplifies things on the disposal end.
That's a big plus. And it seems like this field is always coming up with new and better ways to treat wastewater. What's on the horizon? What are some of those cutting-edge technologies that are emerging?
One exciting area is membrane technology. They use these semi-permeable membranes to filter out contaminants based on their size and charge.
It's like having a microscopic sieve separating the good stuff from the bad.
Exactly.
What makes membrane technologies so promising?
Well, they can achieve really high purification levels, like they can remove even the tiniest contaminants. And they're very efficient and adaptable to different applications.
Hmm.
You can use them for polishing effluent or even enabling water reuse.
That's really impressive. Any specific types of membrane systems you'd like to mention?
Sure, the membrane bioreactor, or MBR, is a great example.
NPR?
Yeah. It combines biological treatment with membrane filtration, all in a small footprint. It's a very elegant solution.
It's like a one-stop shop for wastewater treatment.
Right.
So there are a lot of options out there. It seems like choosing the right one for a specific situation could be pretty challenging.
Oh, absolutely. There's no magic bullet, no one-size-fits-all solution.
Right.
You have to consider the type and concentration of contaminants you're dealing with. The
Mhm.
flow rate, regulations, budget, all those factors come into play. That's why it's so important to work with experienced wastewater treatment professionals.
They can help you navigate all those complexities.
Exactly. They'll analyze your specific needs and guide you toward the best option.
It sounds like expert advice is crucial in this field. Now, we've talked a lot about the technical side of things, but something I've been thinking about throughout our conversation is the environmental impact of wastewater treatment.
Yeah, that's a crucial consideration.
We've discussed some amazing technologies, but what about sustainability? How do these advancements fit into our efforts to reduce our environmental footprint?
That's a great question. We're seeing a big shift in how we think about wastewater. Instead of just treating it and disposing of it, we're starting to see it as a potential resource.
So from disposal to recovery and reuse.
Exactly. It's a whole new way of thinking.
Can you give us some specific examples of this resource recovery approach?
Sure. One big one is biogas capture. A lot of municipal treatment plants now have anaerobic digesters. They break down the organic matter in sludge, producing biogas, which is a mixture of methane and carbon dioxide.
Okay.
And you can use this biogas to generate electricity or heat, offsetting the plant's energy consumption and reducing its reliance on fossil fuels.
So the wastewater is helping to power its own treatment. That's amazing.
It is. And another area is nutrient recovery. There are new technologies being developed to extract valuable nutrients like phosphorus and nitrogen from wastewater.
Okay.
And those recovered nutrients can be used to make fertilizers, reducing our dependence on mined resources.
It's like closing the loop, turning what we used to consider waste into a valuable resource for agriculture.
Exactly. It really highlights how our perspective is changing. Wastewater isn't just a problem, it's a potential solution.
This is all so fascinating. It's clear that the world of wastewater treatment is evolving rapidly, driven by both technological advancements and this growing awareness of our responsibility to the environment.
Yeah.
But I'm curious, how does this broader context relate back to DAF technology?
Ah, good question. Remember our case study focused on a municipal wastewater treatment facility using DAF for algae removal, right?
Right.
Well, the basic principles of DAF can actually be applied in lots of different contexts, including industrial wastewater treatment.
So DAF isn't just limited to battling algae in lagoons.
Not at all. DAF is great at removing suspended solids, and that includes algae, of course.
Okay.
So it's a versatile tool with potential applications across various industries. You could use it for pre-treatment in an industrial setting to get rid of suspended solids before more specialized treatments, or you could integrate it into systems that are designed to remove specific things like oils or heavy metals. It can help enhance their separation and removal.
Wow, this really opens up a whole new perspective on DAF. It's not just about algae, it's about applying its unique strengths to solve a variety of challenges in wastewater treatment.
Exactly. And as technology keeps advancing, I think we'll see even more creative and innovative uses for DAF. It's all about making wastewater treatment more efficient, more sustainable, and more resource conscious.
This has been a really eye-opening journey through the world of wastewater treatment. We've explored the challenges of algae, the complexities of industrial wastewater, and all those incredible advancements that are pushing this field towards a more sustainable future. But before we wrap things up, let's bring it all back to our listener who might be facing their own algae problems.
Good idea.
We've learned a lot, but what are the key takeaways for someone dealing with an algae overgrowth in their wastewater treatment system? So we've learned about algae overgrowth and how DAF can be a real solution. But if our listeners dealing with this issue, what are the most important things for them to think about?
Well, Understanding what's causing the problem in the first place is key.
Yeah.
We've talked about all those factors that contribute to algae blooms, too many nutrients, warm temperatures, lots of sunlight.
Right.
You really need to address those underlying factors if you want to control algae in the long term.
It's like weeding a garden. You can pull out the weeds, but they'll just keep coming back if the soil conditions are right for them.
That's a great analogy. So, yeah, figuring out where those excess nutrients are coming from is a huge first step. Is it agricultural runoff, industrial discharges, leaky septic systems?
Right.
Once you know where they're coming from, you can start developing a plan to reduce those nutrients.
So step one, play detective. Track down those nutrient culprits. What comes next?
Well, once you have a handle on the root causes, then you can start looking at solutions. We've talked about DAF in detail, and it's definitely a proven technology for removing algae.
Right.
But as we've discussed, there are lots of other technologies and approaches out there for treating wastewater.
Yeah, it's almost overwhelming how many options there are. Chemical precipitation, advanced oxidation processes, and all sorts of other things. How do you know which one is the right fit?
That's where it's so crucial to work with experts, wastewater treatment professionals.
Okay.
They can look at your specific situation, consider things like the type and amount of contaminants, your flow rate, what the regulations require, and of course your budget. They can weigh the pros and cons of each option and help you make the best, most sustainable choice for your needs.
So don't go it alone. Find some experts who can help you navigate all the complexities of wastewater treatment.
Exactly. And I'd add that it's not just about the initial choice of technology. Wastewater treatment is an ongoing process, right?
Yeah.
It needs to be monitored, adjusted, and optimized over time. Working with experienced professionals will ensure that your system runs smoothly and efficiently in the long run.
It's really a partnership for clean water. We've talked a lot about the technical aspects of wastewater treatment, but what about the human side of things?
Sure.
What advice would you give to someone who's feeling kind of overwhelmed by all of this, managing algae or dealing with wastewater treatment in general?
Well, first of all, know that you're not alone in this.
Where?
There are tons of resources and people who can help you. There are other professionals in the field, industry conferences, online forums, all sorts of things. Don't be afraid to reach out and connect with others.
Yeah.
Sharing knowledge and experiences can make a huge difference.
It's all about building that community of support,
Absolutely.
learning from each other, and tackling these challenges together. And speaking of working together, I think it's important to remember the role of public awareness and education when it comes to wastewater treatment.
I agree.
We all contribute to the wastewater stream, right? So understanding how our actions impact water quality is crucial for creating a sense of shared responsibility.
For sure. Raising public awareness about things like using water responsibly, disposing of waste properly, and investing in sustainable treatment infrastructure is so important if we want to build a more water-conscious society. It's about recognizing that clean water is a shared resource that we all need to protect.
Well said. And speaking of protecting clean water, I think it's a good time to wrap up our deep dive on a positive note. We've explored some tough challenges, but we've also seen some really amazing innovations and a growing commitment to sustainability in this field. It's inspiring to see how human ingenuity and care for the environment are driving us toward a cleaner and healthier future.
Absolutely. The advancements we've talked about, like DAF technology and resource recovery, they show us that we can actually transform wastewater from a problem into a solution. By embracing innovation, working together, and raising public awareness, we can create a future where clean water is plentiful and available for everyone.
That's a great note to end on. So there you have it, folks, our deep dive into algae and wastewater treatment. We've gone from the microscopic world of algae blooms all the way to the big picture of managing wastewater sustainably. Hopefully you're leaving this episode feeling informed, empowered, and maybe even a little inspired.
It's been a pleasure joining you today.
And remember, everyone, every drop counts. By taking an interest in wastewater treatment and making choices that protect water quality, we can all play a part in creating a brighter and more sustainable future.
Until next time, keep learning.
Keep learning.